So I just want to do a really quick update to share with you some quite exciting new features in Shaderian. Right, this is something that you weren't able to do with the old versions, but now with this new feature, you're able to do it quite easily. So hear me out. Normally, when you do 3D graphics in a single shader pass, like on the shader toy, what you would do is to set up a ray marching loop, right? And in the ray marching loop, there is some kind of mapping function that gives you the closest distance to some arbitrary surface, which is how you would get interesting looking shapes, right? So I can just render this. As you can see, it's a sphere, it's a torus, it's a plane. It's not very interesting. The point of this is to demonstrate the lighting you get. You can do some fake global illumination or smooth lighting, whatever you do. It's always going to be a hassle to just put in those hacks, and they're not general purpose at all. They only work for the scene you're rendering. So what you could do now in Shaderian is a different way to render, right? Is to pathtrace, and you can see how fast they converged. Normally, a path tracer or a ray tracer, it takes a long time to get a relatively noise-free image, but now we got one pretty fast. And you will probably say, okay, dude, there is just a sphere, just a torus, just a plane. It's not even hard to do it on a CPU with the same speed. I'm going to have to say you're right, except that the advantage of doing procedural modeling with sign distance field or distance estimation functions is that you can render almost any arbitrary surfaces that looks quite interesting, right? An example of that is manobulb fractals. Here is a manobulb fractal with the power of 2. It doesn't look that interesting in the basic Lambert lighting, but if we turn that on, you can see it's a lot more interesting now. There's a lot of details. You can see light bounce around in the crease, right? And there's, because the direct light is coming from right to left, you can see some shadow on the bottom left, and there's bounced lights from the green fractal down to the yellow surface, and there's some green tint on the ground. It's just a lot nicer than just the normal lighting. How did I do that? Well, what I did is to do this, just to do the standard path trace with one sample pixel, then you interpolate that with the previous frame. And that is something, accessing the previous frame is the key here. The new feature I added is just the index number that keeps track of how many frames you have rendered so far, and access to the previous frame as texture. This way you're able to keep track of the previous information by accumulating them in a single texture, then propagate it forward into the future, which you can reuse, as you can see in this case, which we use it to do progressive path trace rendering, right? That's why, I mean, that's how we achieve this smooth and fast converging image that is not hanging on a computer, because we separated each sample into a single frame render. And with this, there's also some interesting stuff you can do, like game of life, right? Or you could do game of life before, but then the computation cost grows linearly as the program runs. But now it does not exist, because you can save the computation of the previous iteration into the previous frame texture, which you can access. As you can see, I'm doing just texel fetches, 8 texel fetches to get the neighbors, right? So that's straightforward. And maybe you have noticed, if you keep track of my Twitter, I just tweeted this interesting image, which is just completely path traced, right? I use fractal noise to modulate the terrain a little bit to look like a beach or something. And the nice lighting I get, all of this is just ambient light. There's no direct light at all, and it already looks very interesting. All of this is done using the same mechanism that I just showed you, right? And you can just read this comments when you copy the starter code. I also put all these shaders in the sample section, which you can see as fractal path tracer for the fractal and simple path tracer, which you can just run on your own yourself and look at the code to examine how it actually works. So this is pretty exciting. There's probably a lot more stuff you can do with this. Right? Hopefully you're also excited too. I just think it's a very powerful feature that's worth doing a video, sharing an update.